For this problem, they just ask, what is the final velocity of the disk rolling down the incline? So in this problem, they actually don't give you any numbers. You have to figure out using only the concepts and formulas. So the other thing is that this is at rest at the top, and then it will roll all the way down. So given that, we can start. So energy is not created or destroyed. So the initial will equal the final energy. So energy is composed of kinetic and potential energy, and it will equal the final kinetic and potential energy. So given that, we can start the problem, right? Because since it's at rest, that means that it's not moving, therefore there's no kinetic energy, so we can get rid of that. So it will only be potential energy. So when it rolls all the way down to the ground, when it's at ground level, potential energy will be 0, right? Because mgh, the height will be 0, so there's no potential energy. So now we have a simplified version, right? We have potential energy is equal to final kinetic energy. So now we can plug in what we know for the formulas. So potential energy is equal to mgh. And since this is a disk, not only is it moving downwards, it's also rolling, right? So it's two things. It's the kinetic energy will be 1/2 mv squared of it just moving down, right? And then 1/2 I angular velocity squared because it's rotating as it's moving down. And that also needs energy to roll down like that. So once again, we can plug in some more information so we can see if we can simplify stuff. So I, right, is the inertia, and since this is a disk, the formula for the inertia of a disk is 1/2 mr squared. And then for angular velocity, right, which is this, we can plug in v over r, okay? And that we still have to square it, is that only equals angular velocity. So now since we have that, we can simplify it. So if we square both of these, right, we'll get v squared and r squared. So if this is r squared and it's on the denominator, it will cancel out with this, right? Because it will become r squared divided by r squared, so you just cancel those out. And then after that, we can multiply the 1/2, right? So it'll become 1/4. And then you have the v squared. Our new equation will be mgh equals 1/2 mv squared plus 1/4 mv squared, because the r squared cancels out with this r squared. So now since we have this, we can simplify it even more. Let's make 1/2 2/4, right? Just making the same denominator. So let's make it 2/4, therefore it will become 3/4. So now since we have that, what we actually wanted was the final velocity, right? So to get final velocity, we'll multiply by 4/3, right? Multiply by 4/3 to get rid of this fraction. So it'll go over here. We'll cancel out the mass, right? Because if we divide by mass, the mass cancels out on each side. And then finally, we will square root the velocity. So we'll end up getting 4/3 times gravity times height. And then the square root of that will equal the final velocity. So I hope that helped, and thanks for watching.